So guys, let's quickly dive into the project proper. So this is the project topic is just the accuracy assessment of ASTER grade DEM and SRTM 30-meter resolution over the Federal University of Technology, Owerri. So this is just a study area, alright. So yours can be any study area at all. Okay, so we want to just check which of the elevation model is more accurate for measurement than the other with respect to a reference data which is obtained with the GNSS service. So it can be obtained in real time, all right, and it can also be obtained with the static method of surveys, all right. So those ground control points are used as the reference data, all right, for us to determine which of the elevation model is more accurate than the other. Is it the ASTER DEM or the SRTM DEM? All right, so that's just what we want to achieve in the course of this training analysis. All right, so to do just that, all right, you first go and download your digital elevation model from their online sources. So the first one I'll be downloading is the ASTER DEM. all right, so to download that, you just come to your browse. So I'm going to drop this link, download link. I'm going to give it to you under the comment section, all right, so you can just access it directly. So I'm just going to paste to my search place. So make sure your computer is connected to an active internet. Then I'm just going to click on enter. Right. Therefore, this is the official website, the earthdata.nasa.gov. This is the official website where you can download the ASTER DEM and other remote sensing data for free. But make sure you have an account with them. So if you don't have an account as a first timer, you have to come to login here. So you click on login. All right, so when it load up, you are just going to see the process of registration. All you need is just your email, an active email, and you just follow the procedures. It's quite easy to do. So you have an account with them in order for you to be able to download remote sensing data from the website. All right, so I'm just going to log in so that I'll be able to search for my data and download. So you can see I am already logged in. So that's just my name. That's my name. So I'm already logged in. So you should log in as well. All right. So when you are done logging in, all you have to do is to swipe sideways. All right. So you go to your study area. So this region is Africa. So you just need to zoom out so that you can see your study area so that you can download easily. So this is the highest extent you can zoom on the website. So I will quickly explain how to download the DEM that is going to cover your study area. So in this case now, you are going to see there are different symbol and icon here. So this location icon now is what you will be making use of. So it's a spatial coordinate icon. So you click on it, then you can see it's already reading the coordinates. So you click on this side of the study area. So you can see this is Imo State. All right, let me go out a little. So this is Imo State. You can see the location icon there. All right, so when you click on it, you will come to the search collection. So this is where you are going to select. You can see there are sentinel data, different remote sensing data. So what I want to download is ASTER DEM. So you just type ASTER, all right, DEM, then you click on enter. So you can see it has bring out the option. This is ASTER Global, all right, digital elevation model. Okay, so this is what I'm interested in. So if you want to download NASA DEM, you come here. So there are different, remote sensing data. So what I want to download is ASTER DEM. So I'm just going to click on this. So you can see now there's a green tabs. So this only covers this region of my study area. All right, so if I move this location icon to this part of my study area, you are going to see another green tiles covering this side. All right, so the idea is you are going to download two sets of DEM, two sets of tiles ASTER DEM of this region, so that it can cover the whole of your study area, so that you won't miss out on any region at all. All right, so you can see, for you to cancel this, you just need to click on delete here. All right, then you click on clear all, so it's going to clear. So I want to choose this side of the study area now. Okay, so it's just the same idea. The location icon is what you have to choose. So in case you can't find the location icon, all right, all you have to do is to refresh. You just refresh the website, so it's going to appear. So I want to choose this side of the of my study area to see how the tiles is going to cover that region. All right, so you can see this is this other tiles of the elevation model that covers this region. If I put it here, you see a green tiles that cover that region. So I'm just going to download this. When I'm done downloading this, I'm going to download for the other side of the tiles too. All right, so that is just how to download ASTER data from the NASA website. So to download, all you have to do is to come to this download icon here. You click on that, so you are going to see dem.tif and num.tif. so you just download this. All right, so this is the main data. So when you click on that, it's going to redirect you to the download website. Then just wait for a while. So you can see it's already coming in, so you can just check, and it's coming in. So it's just 60.8 MB. all right, so let me just pause that. All right, so as that one is downloading, you come and download for this region of the tiles. All right, so to download that, you just need to click on remove. All right, then you choose the location icon again, then you choose this part of the study area. So you are going to see the other tiles, then you click on download as well, so that is going to start downloading too. All right, so you can see this is downloading. So let me just resume this. So the two of them will be downloading, so you just wait for a while, it's going to be done downloading. All right, so guys, that is how to download from the NASA website for the ASTER DEM. So when you are done downloading for the ASTER DEM, you then need to go to the website for downloading SRTM DEM. So it's either you go to the USGS Earth Explorer. So here you can get the SRTM DEM also free of charge, but you still need to have an account with USGS Earth Explorer before you can download remote sensing data as well. So I'm not going to use this method here in the course of this training. I am just going to use a method whereby you won't need to be doing the registration on their website. All right, so I'm going to use the Global Mapper application to download SRTM of my study area. So that is just what I advise you use. But if you want to open an account with USGS, it is still fine and good. You just need a whole lot of data to fill the form and all that. All right, so to download the SRTM from Global Mapper, you open your Global Mapper software. So here you don't need an account whatsoever, you just download it directly from the software. All right, so I'm just going to show you that quickly now. So before you do that, make sure you have a shapefile, all right, of your study area. So I already have the shapefile of my area. It is actually photo, so this is a shapefile. So I'm just going to use this shapefile to download the SRTM of my study area. So therefore, for you to use the Global Mapper software, you just need to open into the app. All right, make sure you have your shapefile the way I said earlier of your study area, so that you can directly download for that location. So you load in your shapefile. So I'm just quickly going to load in that shapefile into the Global Mapper. So I have it under my desktop. Okay, so here is the shapefile. So I'm just going to load it and OK. So you don't need to do anything much here. You click on OK. So this is the shapefile of my study area. All right, so when you load in your shapefile, you come to connect to online data. This icon here, you click on that. So here you may not see all these, so what you'll be seeing is all these things. So you just scroll down to terrain data. Alright, you click on that. Then you can even see ASTER Grid DEM version 3, but you won't be having access to download here. Alright, so the only one you can have access is the SRTM worldwide elevation data 1 arc second. So you click on that, then you click on connect. This is the SRTM DEM of this my study area. So for you to download directly is quite easy. All you have to do is to convert to TIF. Alright, so you click on the SRTM worldwide elevation, you right click, then you scroll down to layer, then you click on export layers to new file. Alright, so here you make sure this is checked. If this is not checked, the SRTM, you check it, you click on OK. So you can see already the DEM option is there. So these are different formats you can export this DEM as. So I'm just going to export it as DEM. Alright, so you export as DEM, then you click on OK, then OK. So here you have an advantage to clip the region of interest if you don't want all the DEM that is outside of your study area. So to do just that, you will click on export bounds. Okay, then you will click on use layer bounds. Alright, so you check the study area, okay, photo area shapefile, so that it can download and export just this region for us. Alright, so you click on OK. So you can see the square already. It's just going to export this so that you won't have excess large files, alright, exported. So when you do that, you click on OK. So here you can now name this, then you define the folder you want it to go into. So I want it to be under DEM access, so I'm just going to give this SRTM. Alright, so you click on save. So that is just all in global mapper. You don't need to do anything more. So successfully, let's check the folder. So inside the folder we have successfully downloaded the SRTM DEM of the study area and the ASTER Grid DEM as well. So that's the first thing to do in downloading your data from the online sources. So the next thing is to come into ArcMap. You open that so that we can extract the elevation of the GCPs with respect to their positions. Okay, so the first thing you do on ArcMap when it's opening is to define the layer. So I want my job to be under the Nigeria Traverse Mercator, the mid belt. So you scroll down to properties, you come to, if yours is not on any of this, you come to coordinate system, you click on projected coordinate systems, then you click on national grids, then you click on Africa, then you scroll down to mid belt. So here, Nigeria mid belt, this is where I want my job, the coordinate reference system, to be on. So you click on apply and OK. So when you are done with that, I am going to paste my CSV of the ground control point. Alright, so I already have it in one of this folder, so you should have it saved inside your folder for easy access as well. Alright, so I have it as so this is the ground control point. So I'm just going to paste it inside of this folder. So let me quickly rename. So I'm going to call this GCP ground control point. Alright, so this is my ground control point in Excel. So you can see how it is tabulated. So it does not matter how it's tabulated. The major thing is that there should be the coordinates, northings, eastings, and the elevations respectively. Alright, so this is how it's supposed to be. Then you import the DEM inside the ArcMap. Alright, work environment. So I'm just going to quickly go to the folder where I have the jobs. So I'm just quickly going to go into the folder where I have the data saved. Alright, so it's actually under my desktop, DEM access. So this is just it. So I'm going to import the SRTM DEM, so you can see it here. So don't mind this, we are still going to project it because the default coordinate system of the SRTM downloaded from their online sources is on the geographic coordinate system. However, I have set up my coordinate system as the Nigerian Traverse Mercator, which is the main datum system. Alright, so it's going to conflict each other. So but later in the course of the training, I'm going to show you how to project. So you click on close. So this is the SRTM of my study area. So when you import that, the next thing is to project. Alright, so I'm going to project this to the Nigeria Traverse Mercator. So to do that, you will come to your search button. So in case your search is not here, alright, you will just need to come to this icon here, search. Alright, so you are going to see, so you click, so you search for project raster. Alright, project raster, so you search for that. So here you are going to see it, project raster. That is the first option. Alright, project raster data management, you click on that. So here you are going to input the raster, which is the SRTM DEM. Then you can see the default coordinate system WGS84. Alright, so you don't need to do anything much here. Okay, so it's actually the, so in case you want to define the folder where you want it to go, but I'm just going to leave it at the default folder. Alright, it's under my document under ArcGIS, and this is the name SRTM project raster 1. So the coordinate system, now this is the major thing. What we want to do here is to define the projected coordinate system, which is under projected coordinate system. You come to national grids, you come to Africa, then you scroll down to the Nigerian mid belt, alright, or any coordinate system of your choice. Alright, so that's just it. So this one is optional, you don't need to do anything here. Then you click on OK. So you just wait for a while, it's going to show OK. So it is green, that shows it's a success and it has appeared here. So all you have to do is to remove this. So we are going to be working with this. This is now on the Nigeria Traverse Mercator, the NTM projection system. Alright, so the next thing now to do is to import the ASTER DEM. So this is the two ASTER DEM for the two tiles. Okay, so you click on close, so you can see it already. So you can uncheck the projected SRTM. Alright, uncheck it. So these are the two. So you can see these are the two tiles downloaded from the NASA website. So I'm just going to import the study area shapefile, so you understand why it is necessary to download a tiles that covers the whole of your study area. So here just going to navigate to where the data is. So let me just go here, and this is it here, photo area. So that's the shapefile. So you click on close, so you can see it now. Alright, you can see that the shapefile crosses through the two tiles. Alright, so if you just downloaded one of the tiles, you can see that there is going to be a lapses. So that is why it's good to download the two or the whole of the tiles within the study area. Okay, so when you are done, so when you import this, so when you import the ASTER DEM, alright, so we need to merge these two raster together as one. So that is the advantage of doing this training, so that you can have all professional basic understanding behind this project. Alright, so to merge these two raster together, all you have to do is to come to the search icon as well. So this time around you will type merge raster. Merge raster, then you click on search. So you are going to see different options. So the options you are going to choose is this: mosaic to new raster data management, mosaic to new raster data management. Alright, so you click on that. So here you are going to input the raster. So it is just the two ASTER DEM. So you click on the first one, then you click on the second one. So these are the two raster that I will be merging. Okay, so output location. So you are just going to come to any of the folder. Okay, any of the folder. So let me put it here on this folder. Alright, So here the raster data name with extension, so this is the name you want the merge data to carry. So I'm just going to call this merge ASTER, right? Merged ASTER. So here this is the spatial reference for raster, okay, is optional. However, I am going to define it, okay, as the projected. So you will not need to go and reproject later on, okay. So you just scroll down to Nigeria mid-belt and okay it, okay. So the pixel type now, all right, this is where you will come here to get the information of the pixel type of this raster. So you will click on the ASTER DEM, one of them, scroll down to properties. So here you are going to get the information. So the pixel type here, you can see it is signed integer, and the pixel depth is 16 bits, okay, signed integer 16 bits. So you just need to so you now close this, okay, then you come here. So signed integer 16 bits, so this is it, 16 bits signed, all right. So that is it, you click on that. So the set size now, okay, is optional, but it is good you put it so that you can have a better result. So you still come to the layer, the ASTER DEM, go to properties. This is the cell size, so it is the same thing, all right. So you just need to copy one of it, you just copy one of it, all right. So you paste it here. So here the number of bands, you come here to get that information as well. So number of band is 1, all right. So that is the number of bands, so you just click 1. So you don't need to do anything much again, all right. So you just click on, make sure that this music operator optional is on last, this is on first, so that you can have better results. So you click on OK. So you can see successfully done, and you can see it is now one raster, not two rasters, okay. So it is now one raster, therefore you just need to remove this, you do not need this again. So we have successfully merged the two rasters together. So when I load my study area, you can see it covers everything once. So guys, that is just the idea, so please follow up carefully as we forge ahead. So that is not all. So this is for the ASTER DEM, and this is for the SITM DEM. So alright, so I don't need the study area anymore. I just actually use it to explain what I did based on merging of raster. Alright, so I've merged this raster. So the next thing now is to extract the elevation of the ground control point from the DEM. So I'm going to show you what I mean. So the next thing to do is to import the CSV Excel file. So I'm just going to scroll to where I have the Excel. So this is the GCP ground control point. You click on add. Alright, so it's going to appear under your layer. You right click, you click on display XY data. So here the X feed is the eastings, the Y feed is definitely the northings, then the Z, very important, is the elevation. Alright, so you can see it's on Nigeria mid-belt already. So you click on OK, then click on OK. So guys, this is just the ground control point overlaid on the ASTER DEM. So you will have to extract one DEM first, then the other DEM the next. Alright, so this is, let me just make it bold. So these are the points, all right, the ground control points. So the idea of extracting this ground control points with respect to the DEM, so you can see, let me zoom out well, you can see these are tiles. You can see each grid is standing for each elevation, all right. Each pixel grid is standing for elevation. So to check the identity of each grid, so to check the identity of each pixels, all right, you will click on this ID here, this identifier, you click on it. So if I click on this particular, let me zoom in a little bit. If I click on this particular grid, this pixel is going to give me the ID, all right, the pixel value. So the pixel value is 64. That shows that the height of this region is 64. So let me choose a particular grid with ground control point on it. So this grid now, alright. So if I click on this to identify, you can see the pixel value is 58. That shows that this region is 58 meters based on ASTER DEM data. Alright, so but the ground control point now, alright, that is obtained in real-time kinematic. Let me click on that. You can see the height here, the elevation here is 58.9471. that is the original elevation, while the ASTER DEM is given 58. Alright, but the ground control point is 58.94. You can see the difference now. Alright, so that is the aim of this particular training. So I'm going to use Excel to do the analysis as we forge ahead, but what we want to achieve here is to extract the DEM elevation with respect to the ground control point position. Okay, so to do that now, all you have to do, let me quickly zoom to layer so that you can see all of it. So this is the whole of the ASTER DEM, by the way. So alright, so to extract this DEM elevation with respect to the ground control points, alright, you come to the search icon, then here you type extract points, alright, extract points, then you click on search. So here now you can see the various informations. So what you'll be clicking on is extract values to points. This extract values to points, so you click on that. So in this particular box, you input the point features, which is the CSV, ground control points. Alright, ground control points. So here input raster, you will click on ASTER DEM, the merge ASTER DEM. Alright, you click on that. So here you can choose to rename. So here I'm just going to call this ASTER points. Alright, so this is the ASTER points. Alright, okay, so you click on save. So that is just the idea. Then you click on OK. So the arc map is going to extract the elevations. You can see it's already done. It has extracted the values of this DEM with respect to the ground control points. So you can see this ASTER point. Now you are going to click on it, right click, then open the attribute table, then you will see the full information. Alright, so you can see now this is the original ground control point, the northings, eastings, the elevations of the ground control points. Then the raster value now is the DEM of the ASTER values. Alright, so this is the pixel DEM values. So that is just the idea. So the next thing now is to export this attribute table to Excel. Alright, so to do that, you come to this icon here, table options, you click on that, then you scroll down to export, click on that. So make sure this is on all records, then you click on this browse icon here. So here, file as type, you click on text, then here you are going to rename this. So I'm going to call this ASTER data. Alright, then make sure it is dot small letter CSV. Okay, so this is the Excel extension format, asterdata.csv. You can see how I saved the name. So you click on save. So before you click on that, make sure you are saving in the folder of interest. Okay, so you click on OK. So it will ask you, do you want to add this new table to the current map? No. Alright, so you close this. Okay, so we are done extracting the elevations with respect to the ground control point for the ASTER DEM. Alright, so the next thing we want to extract is for the SRTM DEM. So you uncheck the ASTER points. Alright, leave the GCPs. Okay, this is the original ground control point. So therefore we are going to extract for the SRTM next. It's the same process. You come to the search icon, extract points, come to extract values to points, click on that, then you come to input features, that is input point features. You click on the GCPs CSV, not the ASTER point, GCPs. Alright, CSV, then input raster. This time around it is the SRTM projected raster. Okay, then here you can now rename. So I'm just going to call this SRTM point. Alright, so SRTM point. So don't leave a space, make sure there is an underscore to join them. Alright, so you click on save, then you click on OK. So this is already done as well, SRTM point. So therefore you will come to the SRTM point on your layer, open attribute table, so you can see it. So this has actually extract the elevations point for us. Okay, so the next thing to do, okay, is to export to CSV. All right, so you come here, the same process as before, then you rename. So this time around SRTM data, remember .csv. so you click on save and OK, then no. So that is just the idea of extracting the elevations from the GG2 elevation model from the raster. So when you are done with that, the next thing is to come into your Excel. Alright, so you just go to the folder where you have your ASTER data and the SRTM data. So this is the SRTM data, the Excel data. You open it, so you can see it here already, SRTM. Okay, so for the ASTER data, here it is here. So we are just going to open it, so you can see this is not actually in decimal, so but it's okay. So here is where we are now going to start doing the analysis. So I have numerous data for different individuals. I'm going to use the data for this first individual. All right, so I have the base here, so this is an individual. I'm just going to delete this first point, that is like an outlier. All right, so these other individuals now I'm going to drag them below so that you won't get anything confused. So give it a space here, then paste them here. Alright, so this is the individual data I want to use. So this is for somebody, so I'm going to be using this as a sample data. Alright, so the same thing I'll be doing here is the same thing that is applicable to these individuals. Alright, and also if you have your data once, maybe this is just all data for one individual, you can run the whole data at a go. It's the same process. Alright, there's no cause for alarm, it's the same process. So I'm just going to use this as a sample. Okay, so to run your analysis on Excel, what three things we want to find out: the mean error, alright, the standard deviation, and the root mean square error. These are the parameters that will determine which of the DEM is more accurate than the other. Alright, the mean error, the standard deviation, and the root mean square. These are the parameters we want to use the Excel to compute for. Alright, so here I'm just quickly going to denote this with GPS elevation. Alright, and here is DEM elevation. So that's just the idea: GPS elevation, DEM elevation. Alright, so I'm just going to let it to be in 3 decimals for that which is on decimal, 3 decimal. So it's okay this way: GPS elevation, DEM elevation. So here I'm going to have a column for error. Alright, so that is the differences between the reference data, which is the GPS obtained in static mode or the real-time kinematic mode of surveys, then the DEM elevations, the one extracted from the elevation model using ArcMap. Alright, so that is just the idea. Alright, so error here is the differences between them. So this is for ASTER data. Now I'm going to do the same thing for the SRTM data. Alright, drag that one down. Then here I'm going to delete this, so it's like an outlier. Alright, so I have 10 sets of data like sample points. Alright, okay, so I'm going to make this 3 decimal, and 3 decimal, and okay, this is okay this way. So here I'm going to call this GPS elevation, and here DEM elevation. Alright, so here is error column, error. Alright, so that is the idea. So let me start from the ASTER DEM data. Alright, so on Excel, so like I said earlier, what we want to get is mean error, standard deviation of the error, and the root mean square of the error. Okay, so what you are going to do to get all that is, firstly, we need to get the differences between these data. All right, what we are considering is the elevation. We do not have business with the position, the coordinates. All right, we are dealing with accuracy assessment of elevations. All right, so first thing to do is to get the differences by clicking on the first cell. All right, you click on equals, then you click on the cell of the GPS elevation, click on that, then minus, you click on the DEM elevation, then you click on enter. So you can see here negative 0.1347. You can actually use your calculator, you are going to get the same thing. Okay, so just to repeat that command, you click on the cell, then you come to this small icon here. So let me make it bold a bit, this little plus icon here, then you drag it down to the last data. So you can see this is for SRTM data. All right, we have almost negative true. Okay, so let's say you want to do for this same information here, it's just this same individual. Let's say you want to do for this individual, it's the same thing, just equals, all right, the GPS elevation minus the DEM elevation, then enter. So here you click on the cell, then the plus sign, you drag it to the last point of that individual, which is David. Okay, so here you can see it is mixture of negative and positive. All right, so that's just the idea. So I'm just going to stick to this first individual as my training data. All right, so these are the error for this particular individual for SRTM data. Okay, so the next thing is to get the average of this mean error. Okay, the average of this mean error. To get that, you just need to highlight on the error from beginning to the end. Okay, let me make it a little bit down. All right, you highlight from beginning to the end, then you come to this icon here, you click on that, then you click on average. So here is the average. All right, so I'm just going to come here and call this, you can call it mean error, ME. Okay, ME equals this. Then the next thing I want to get is the standard deviation. All right, STDEV, standard deviation equals, then the next thing I will be getting is the root mean square error of this particular data. All right, therefore, to get the standard deviation of the error, you click on the cell, this, okay, then you come to this icon here, you click on the drop down shadow arrow there, you click on more function. All right, so you can see it here, standard def. In case you can't see it, you can come here, then you search for it, standard deviation. Search for it and you click on go. It's going to bring out all other information, so you just scroll to standard def. All right, this is it, standard deviation, then you click on OK. Then here you are now going to highlight from beginning to the end of the data. Don't click on the mean error data. Okay, don't click on the results from the beginning of the error to the last point of the error. Okay, so when you click on that, you click on OK. So this is the standard deviation of this particular SRTM data. Then the root mean square error, now you can check your textbook. Statistically, it's just the square root of the standard deviation of the population data. Okay, So all you have to do is just to come here on this cell, then you click on equals. So this is a population data, not a sample data. To get a sample data is quite different. All right, so this is population data. Okay, so you can check and consult your textbook for that. So we want to get the square root of the standard deviation, just equals, then you type SQR. So you're just going to see this is square root already. You click on it, double click. So here now you just check on this cell only. Okay, then you close the bracket. Do you get that? Okay, then you click on enter. So this is the square root of this. You can use your calculator. You're going to get the same thing. The square root of the standard deviation is this. All right, so you can now make it 3 decimal. I don't want it to be 4 decimal. All right, 3 decimal is okay. So this is the idea of getting the mean error, standard deviation, and the root mean square error. All right, so I'm done with SRTM data. So I want to do that of the ASTER data. So I'll just come to the Excel sheet of the ASTER data and repeat the same operation I did for the SRTM data, equals this minus this, enter. All right, then you repeat to the last. Okay, so you can see this is like combination of plus and minus, that is positive and negative. All right, so what I want to have now is mean error, standard deviation, and root mean square error. All right, so the mean error is just the average sum. So I'm just going to, like I said, highlight, then average. So this is it here. Then standard deviation, the same process. Come here, more functions, then click on standard def, then click on OK. Then here you highlight the mean error from here to here. Okay, from the number 1 data to the number 10 data. Okay, so of the error, please note of the error. So we want to get the error standard deviation, not the GPS or the DEM. Okay, so you click on OK. So this is the standard deviation. Then the root mean square. Now the root mean square is just the square root of this. So equals SQ. You are just going to see it. You click on it. Then you click on this cell. Then you close your brackets. Then you enter. So that is the root mean square of this this set of observation for the ASTER DEM. So therefore the idea is we want to know which of the DEM is more accurate than the other with respect to the same reference data. So these elevations is obtained with the EGM 1996 model. Same way for the other one we use for the ASTER DEM, same process, and we want to know which is more accurate. Therefore, the standard deviation and the root mean square error parameters values is what is considered as the major parameter to know which is accurate than the other. All right. So for the ASTER data or the ASTER DEM, the root mean square is, let me make it to be 3 decimal, 2.26. all right, that's the root mean square error, 2.26. Why that of the SRTM is 1.627. so the idea statistically is the lower the standard deviation and the root mean square error, the more accurate the data is. So here you can see the root mean square error is 1.627 for SRTM DEM, and that of ASTER DEM is 2.26. Therefore, we can now say that this SRTM DEM is more accurate than ASTER DEM. So that is just the basic idea of this project. That is just the basic idea. So we can make a judgment that the accuracy of SRTM 30-meter resolution is better than ASTER DEM of 1 arc seconds. Okay, that is just it. So to get a template of this project, you can join my WhatsApp community or you email me to get a template. Please, terms and conditions is applied. All right, so guys, that is just how to check and assess the accuracy of DEM. So you can use another set of DEM. You can use TanDEM, you can use NASA DEM, you can use different DEMs and check which is more accurate for analysis, for measurements, for observations, and the likes of it. Thank you. If there is any question, do well to drop it under the comment section, or you can join my WhatsApp community. See you in the next video.